All right, ladies and gentlemen, we are on to lesson 5.15. Our objective this round is to continue comparing fractions that have different denominators. So we're going to find common units or number of units to compare the two fractions. So the first two fractions we're going to look at are 3/4 and 4/5. And what I'd like you to do is I would like you to draw two squares or rectangles, one on top of the other, two separate ones. You're going to split one into 3/4 and one into 4/5. So you'll have two rectangles, one on top of the other, they're area models, and make one 3/4 and one 4/5. Pause while you do that. We have reasoned this out before, and we've said that 3 parts out of 4 is smaller than 4 parts out of 5 because you only need a fifth to finish, or you need a fourth to finish. And since fourths are larger, we're further away here. But if you drew yours, they should have been about the same size. That's what you're going for. You want to be able to compare them same size. So what we're going to do now is we're actually going to partition our area models so that we can have a like denominator. So if we look at these, we know we have different denominators. We need to get a similar denominator that's going to work for both of them. So multiples are very important here. If I think about my 4, I think of my multiples: 4, 8, 12, 16, 20. From my knowledge of math, I know that 20 works with 5 because it ends in a 0. But we're going to count it anyway. 5, 10, 15, 20. Do you see how they both have 20 in common? That means that we want to get this broken into 20ths and this broken into 20ths. Well, since there are four sections, well, I know 4 times 5 is 20. So what I'm going to do is I'm going to use a dashed line to go ahead and split mine up into fifths as best I can, not adding or changing. Go ahead and do that. And then, since there are 5 here, and I want to make it 20ths, you're going to split it up into 3 dashed lines, because that should give me 20ths. So make 20ths in both of these. Pause while you do it. So here's what yours should have looked like. So our 3/4 became what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it became 15 out of how many were there? Well, we made 20ths. 4 times 5 gives me 20. 3 times 5 gives me 15. So my 4/5 I had taken and I had divided up so that I had 20th as my denominator. How many pieces are shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. They are awful close, but 16 20ths is obviously bigger. Therefore, 4/5 is bigger than 3/4. Equivalent fraction. We were able to make the same denominator because 4 and 5 have 20 in common. We're going to go ahead and compare 5/3 and 7/4 using our number bond to break them down into the whole and the part that's left. Go ahead and pause while you do that. If you did that, you should have come up with 2 fractions. And you should be able to add those together to equal what your whole was. Let's take a look. 5/3 broke down into 3/3 plus 2/3. That equals 5/3. 7/4 is 4/4. That's your whole. Plus 3/4 is 7/4. You can also use an area model to represent, to compare. Because since this is a whole and this is a whole, we're really just comparing 2/3 versus 3/4. So let's actually draw out 2 area models. I do them one on top of the other. Make one 2/3 and make one 3/4. Pause while you do this. If you look at your area model, you're going to see that 2/3 is just a hair less than 3/4. If you wanted to, you could figure out what 3 and 4 have in common. 3, 6, 9, 12, 15. I'm going to go that far for now. 4, 8, 12. Oop, ding, ding, ding. They have 12 in common. So 2/3 equals how many 12ths? Well, I know that I did 3 times 4, so 2 times 4. That equals 8. So now if I want to look at my 3/4, how many 12ths? 4 times 3, 3 times 3. Which is bigger, 8/12 or 9/12? Obviously 9/12. And if you want to cut this so you have 12 equal pieces and you can see it, go ahead. But we have just proven that 7/4 is larger by 1/12. We're going to compare 6/4 and 7/5. And in order to do that, again, we're going to use that whole plus a part. So you're going to break down both of them. See if you can figure out which one is larger. If you need to draw the area model, go ahead. If you need to find the common denominator, go ahead. I'm going to show all of that on my paper when I'm done. Go ahead and pause. All right, so what I've done here is I have taken our 2/4 and our 2/5, and I have found a common denominator. I used my multiples to help me. So I got my 20ths, and I said 4 times 5 gives me 20. What I do to the bottom, I do to the top. 2 times 5 gives me 10. Now this is a brand new problem, so my multiplication may be different. They're not going to be the same. That's okay, because this is one problem. So here's a new problem. How do I get from 5 to that common 20? I multiply times 4. What I do to the bottom, I do to the top. And 2 times 4 is 8. So what we're going to do is we're now looking at which one of these is larger. Well, the 2/4 is larger than 2/5 by 2/20. What that really means is that 6/4 is larger than 7/5. Remember, we took out that whole. Can't forget about the whole. So it's really like saying 1 and 10/20 and 1 and 8/20. Those ones are a wash because they cancel each other out. All right. What I'm going to ask you guys to do next is actually show that multiplication process side by side so that you can see how we are decomposing those fractions into smaller units. Because remember, the bigger my bottom number, the smaller the pieces. So I'm going to give you a fraction, and I'm going to give you lots of space. This may look familiar, and that's okay, because we've already done this one. What we're going to do is we're going to find a common denominator for 5 and 4, and we're going to use multiplication to get that equivalent fraction. If you need to do it one under the other, that's fine, then compare after, go ahead. So get a common denominator between these two so we can actually compare them. Go ahead and pause. All right, if you did that out, here's what it looks like. You should have gotten 4/5 is equivalent to 16/20, and 3/4 is equivalent to 15/20. Therefore, 4/5 is larger. Go ahead and get a problem set and find a partner to work with. And good luck.